Hello, thank you for joining us and welcome to today's webinar about evaluating your assessment program using multi-test analysis. We are joined today with our host, Jason Martinez, Senior Training and Implementation Specialist, and I'm your moderator, Armando Sierra, Professional Services and Operations Manager. The team has two objectives for today's webinar. One, we will set up multi-test analysis and ensure that the appropriate rights are assigned to users. And two, we will identify how to evaluate your assessment program using state data. And with that, I would like to send it over to Jason to get us started. Jason, take it away.
All right. Thank you, everyone, and happy to be with you. Want to direct you to a QR code here for our previous webinar on what is multi-test analysis and a more broad description of the different kinds of way it can be used. Also, it has steps on creating it, which we are going to redo today some, but today is more of a focus on your local assessments in comparison to the STAR data that obviously we know is just now being released from the state. EOC data has been released, and a lot of you, if not all of you, have uploaded that EOC data into Aware. And so you might be thinking, can we compare either our local assessments or different kinds of assessments to that STAR more cumulative summative test and see if we have any correlation or predictability from those smaller local assessments that can be used for that. So this webinar today is very specific in that it's going to be looking at your local assessments in comparative to some summative test. Multi-test analysis has a lot of uses, and so to please once again refer to this past webinar on other uses and more generic information about multi-test analysis in general. Okay, let's hop over into the actual interface. I have a sample fake MTA example here using biology. So EOC data, as I've said, obviously has been released, and all of you have probably uploaded that. Yes, it's the preliminary file, and we do not have standard level data. We do not have item level data, but we do have those overall scores like scale score, performance levels, and so on. So we can use those kinds of scores, those kinds of metrics to do some comparison. And we are going to continue that conversation that starts in that previous webinar about trying to determine what is a consistent and proper metric to use when looking from a local assessment, some other third-party assessment, and obviously a state assessment. And those are the conversations that you're going to have, make those decisions, and obviously, hopefully, those kinds of discoveries that you have through MTA really drives your local assessment program to be changed, if necessary, into the ways that help us make the conclusions about local assessments that we really like to have. So this is kind of after the setup. And so we're going to actually go back into the settings and talk about how we got here. And then we'll stay here and then move toward correlation here in a few minutes. So I'm going to go back into the settings and edit the properties. As you build a progress profile, it starts with you giving it a name, picking a subject area, which is actually a course, which brings in our subject area. And then you select which test types are you going to include. And then of those test types, it will list out all the assessments that are available for that course, grade level subject. And then you're going to select whatever assessments you need to do in order to compare these with multi-test analysis. Once again, kind of referring back to the previous webinar, it will state that you have a maximum of 20 tests that you can use here. I think that's a pretty long list anyway. And so you see I've chosen here some unit assessments, obviously, which would be smaller, more, unit type, only a few standards probably being tested in these units. I brought in the benchmark we did in the spring that we locally developed here, and then we also have obviously the STAR results that have come back from our state test. Once you do that, then you're going to determine a minimum of 2 achievement levels and a maximum of 6 that is going to be comparative for all of those assessments. So this is where you have to start thinking. I know in STAR we have did not meet low, did not meet high. We have those indicators that are up to 6, right? We have 6 indicators. But if you're doing a local assessment that doesn't have that many levels, that many indicators, how are you going to match that? Are you going to do different kind of series of raw scores or scale scores for your star versus a percent score on your local assessments? So anywhere from 2 to 6 is the amount of achievement levels that you're going to create that common metric on. And this is just the name of them. Our default name is achievement level, as you see. You could name it something different, give it a description. I just left our default, but I'm using 3. And then when I click next, this is where that calculation kind of comes into. And this is where you almost need to understand going in that some of this is going to be changed after the fact. There may be a need to do some scoring levels different on your achievement levels than what you might have done on performance levels on your local assessments. So what I've done for STAR, because I'm using 3 achievement levels, obviously with a state test, we think about approaches, meets, and masters as being the common known performance levels, or in this case, an achievement level. So for biology, I've already gone in, and I'm using scale score. So for the scale score for biology, to be approaches, you have to be 3550. To be meets, you have to be 4,000. To be masters, you have to be 4,531, obviously, or above. These are greater than and equal to, as you see. And then we have all of our local assessments. Now, this is where it's going to be truly locally determined. We might have built a test for a certain reason back in Unit 7, and we might have had our performance levels that are nothing anywhere close to these percent scores. Our performance level for maybe it's called developing or something like that, or level 1, or whatever you call those performance levels that were locally developed, those percent scores may not be anywhere close to what you end up putting here. And you got to keep in mind that that's okay, because you're building this to have a comparative from this test to this test. And so if you'll go look at the percent score for biology, for example, that gets approaches, I think we've determined it's like 26 point something percent. And so even if I did percent score, are we really going to put like a approaches level for our local unit test at 26%? And so you want to find a balance or a good level of number to where we're going to think this is where that level of intervention or that level of student is going to fall on our local assessments. And does that correlate to where they fall on the STAR test? So I have all these assessments put in. I've gone in and made these settings here for the scores that I've chosen to start with. And start with, I think, is a good kind of philosophy there, because once you start seeing the data and start looking at it, you might want to come back and make some changes to find the best place that does what you think it's going to do. Once again, the whole purpose behind giving an assessment in general is so that we can draw conclusions that are valid. Well, you can obviously manipulate the numbers to make it look however you want it to look, but that's really not the goal. The goal here is, can I draw conclusions from how we score on our local assessments to how we possibly are going to score on our STAR test, so that we have some comfort that we're going to be at least be close. Are we developing our local assessments with the level of rigor, the types of different DOK, the types of different question types? Are we developing our local assessments so that we are preparing our students in a way that helps us have a comfort level, at least a little bit, on what we think is going to happen on STAR? And then once STAR happens, does that really prove to be true? So I have labeled STAR here with this toggle as the comparative test. So you only have one comparative test. See, I try to do 2. There's one comparative test that all the other tests, from a standpoint of correlation, we're going to see if each of these assessments correlate to the results on STAR. So that you choose that. You do not have to choose a correlative test, a comparative test. That is not a requirement for MTA to function. Obviously, that is a requirement for the correlation to be available. So I'm just going to go ahead and turn this off to show you that if I update this, the correlation view is grayed out. So if you ever build a MTA and you're kind of intending to try to look at the correlation and you update and you're like, oh, I can't do that, I forgot to toggle that on. Obviously, to be able to go back and edit your properties, edit your settings, these three little vertical dots are where you do that. You click on edit properties and then get back over to where we are. And then remember to toggle on the comparative test that you want. All right, so let's go ahead and update and talk a little bit about here what we're seeing on this page, and then we're going to spend some time on the correlation view as well. So we, once again, as a general operation of MTA, you'll get much more information, in-depth information in that previous webinar. You can look at our online help guide, but essentially relating similarly to quick views. Obviously, we have different levels of where we can see this data. This is at the student or district level. So we're seeing the achievement level comparisons, right, of where the number of students fell for each of these tests. Once again, I use star, that star number for scale to determine achievement level 1, but then I'll use 40% score, of a percent score of 40 for that's where these fell. And once again, you might have to talk about that number, determine, you know, what it is our local assessments mean, or is there going to be consistency or there or not. A lot of thought needs to go into where we place those things. We can see it by the number of students. We can see it by the percentage of students that fall in each of those with this just little toggle. Up here, obviously, we see that visible with a graph, what percentage of students are in achievement level 1, and we can kind of see, does it kind of align? Well, you can see here star at the top. I have all of my unit assessments, and then I have my spring benchmark. So I can kind of already see there's fairly good alignment here. It does appear that a lot more students fell in achievement level 1 on my benchmark than even did on my star. So that's already kind of given me a sense of, well, maybe our benchmark was actually more rigorous than the star test was. And so we can kind of see some of that, draw some of those conclusions right from here. But we got to see, you know, is this test correlative? Can I draw that conclusion? Because is there some kind of mathematical correlation that says there is consistency in the movement, right? So these are where the students scored on each test. But do I know that a majority of the students that were in achievement level 1 on our benchmark were also the same students that were in achievement level 1 on our star test, and so on for these unit assessments as well? So that's the kind of correlation value. Right here, I'm seeing that, yes, overall, the percentages do kind of line up, but it would be weird if some of the students, or say a large percentage of the students that were at achievement level 1 on the benchmark ended up being third achievement level on the star, or vice versa. So if there was kind of an indirect kind of relationship, it would be, you couldn't see that from here because this is not telling you the movement of students. Is there consistent movement? Do students score at the same achievement level from test to test? Or if there's movement, how much movement is there? How correlative is the test? So that's what the correlation view is going to do. So we're going to swap over and look at the correlation view now. Once again, have to have that toggle on for your correlative test to have this option. So once we get here, we have this correlation value over here that probably is the first thing that draws your attention. And once again, we are correlating each assessment to the star. So they're not correlating to each other. Each assessment is being correlated to the star test. So it's a 1-to-1 correlation. There are 2 factors. The star test is 1 and whatever else test, but it is a consistency of that test to star, this test to star, and so on. And so this value that you see over here is the Pearson correlation coefficient. Those of you that are math and stats folks, you can actually go look that up. That is the math being used in the background. And what the Pearson correlation coefficient will state is that to be possible to have a good correlation, you would be looking for a minimum of 0.5. And so you can see I'm kind of right at that minimum here for my unit assessments. Just because it says 0.5 doesn't mean that there's correlation. It just means that there's possible good correlation. Obviously, if you were having something on the inverse, you'd be over here. That obviously would not be something that would be telling you that your test is valid and measuring right, because your students would be the students that got did very well on one test, they would be doing very poorly on the next test, and vice versa. The students that did very poorly would be doing very well. And so if you had a negative correlation, then those tests would be completely backwards of what you would think. And so obviously in the real world here in assessment with students in education, we definitely don't expect to have anything negative, but you definitely want want your correlation to be 0.5 or higher. Obviously, the closer to 1, the stronger that correlation. So you see, as we get down here to our benchmark, it has the strongest correlation. So let's think about that just in general, right? These other assessments are specifically about a particular unit. So you're only testing a certain number of TEKs. And so maybe we're teaching 5 or 6 TEKs in this unit. We're only testing those 5 or 6 TEKs. It's a shorter test. We may be introducing this standard, right? This is the first time we're talking about this with the students. So we may be giving different levels of questions, right? This is DOK level 1. Maybe we're sneaking in a couple of DOK level 2, but this is a new topic for students that we're introducing. And so we're not going to be testing at the same level that we would on obviously a STAR. Well, that conversation is had, and we are thinking about those things on a benchmark typically, because we're giving this benchmark with the intention of replicating the STAR. We might even be replicating the environment, right? We're kind of closing down. Maybe we have different testing groups. We are focusing, surely on the testing supports, making sure that students that are going to be having support is assigned to them. For STAR, we're making sure that we do the exact same thing on the benchmark. We are intending for this benchmark to be a practice type state assessment, because we're trying to prepare our students for that environment, for that kind of assessment. So it would not be shocking that this would be the highest correlation score of a test compared to STAR, because it is the most STAR-like, not only in construction and blueprint of the test, but also in the assessment environment. I'm going to move over to the achievement level comparison, and this will be that movement that I was referring to. This will be showing that movement. Now, right when we get here, and you will be expecting a message on yours and for the next couple of weeks for sure. Let me go ahead and talk about the elephant in the room, the elephant on the page. So when you come here, my assumption and everyone's assumption is that we are looking from the unit test to the STAR test in movement. Let me explain movement, and let me explain why we have just discovered recently that our development team built this kind of backwards math, but it's okay. It's still the same thing. I'll explain it, but it will be changing to reflect what all of our assumptions are. So let me explain that. So first, this 0. Let's start with the 0. And you see, if I hover over the 0, it says no change. So let's refer back to those achievement levels, right? So I'm going to actually go back. We have 3 achievement levels. And if you'll recall, I set those achievement levels. For STAR, it was set via scale score. For all of our other assessments, we used a percent score, but there were 3 different achievement levels. And so what these numbers on the correlation view are in this comparison, if a student scored at a particular achievement level on this test, do they also score that particular achievement level on the next test? In this case, the comparative test, the STAR test. So we would make that assumption. A student scored, let's just say, achievement level 2 on the STAR test. They also scored achievement level 2 on the unit test. I just said that in the order that it is displaying. It's looking at the STAR test right now and showing you the movement to the unit test. So if a student scored achievement level 1 on the STAR test, then from that test, we're saying what was the movement to the unit test. That is the opposite of kind of the intention of this. And so what you're seeing is the opposite of what our mind would say. So let's talk about the students that do move. So right here, we're seeing a -1. Students on the first test moved 1 level down, 1 achievement level down on the next test. So our minds would tell us, okay, that means they scored achievement level 2 on the unit test. Now they're scoring achievement level 1 on the STAR test. That is what our assumption would be. That is what MTA achievement level comparison will be showing very soon. But right now it's looking at it from the STAR test to here. So it's backwards of what our minds are thinking. So all this to say is the way that you're going to see it right now, if you see a -1, it's really a +1. If you see a +1, that's really a -1 in the way that we think about it. Once again, we apologize for that kind of confusion. When we build new things, until we start looking at real kind of data, like we are now, it makes things hard to discover. We just got star data in. We're starting to build real type of MTAs like you are going to, and we discovered it's kind of doing the opposite of what we think it should. Not that it's wrong, it's not wrong, it's just looking at it in an inverse direction of what we think. So let's talk about the table. And if that needs clarity, hopefully, there's, like I said, there's going to be a message, and this won't be long. But if you need clarity to that, please reach out and we'll try to help clarify that. On the tables tab, this is the number of students that move. I think this probably gives us a better clarity of what we're talking about. And so the students in the 0 would be all students that scored the same achievement level on both tests. So the 0 is kind of irregardless of which order, they scored the same. And so if our test is predictive, we want a large majority of our students to be what we predicted them to be. They were at achievement level 2 on our local test. They are still achievement level 2 on our STAR test. We had that prediction. And so when we have this -1, this is saying to us that the spring biology test, okay, students, 548 students had 1 achievement level less on that than they actually did on STAR. Once again, this is backwards. So this should be in the +1 column. So this is that positive thinking. It's that surprise that we want to be surprised with in education. We thought, for example, this number of students were going to be at approaches grade level, but a lot of them actually came in at meets grade level. Wouldn't that be awesome if that was the case? And that is what's proving true in this fake data here, this demonstration data of a large majority of students moved the positive direction from achievement level 1 to 2, from 2 to 3. They had movement in the singular direction that was actually in the surprise that we want it to be. We want them to be moving positive. And so let me go back to that correlation table and talk about it again. So the reason why this is a higher score is because when you look at that achievement level comparison, whether it be the graph or the table, most of the numbers, right, are going to be very few movements. So like if you look at the percentage of students, right, if I look in here, there's almost the same amount of students that were moving, right? Well, and there's a lot of students that might have moved, a larger percentage of students that might have moved 2. And so it had a weaker predictability because we had a broader change. More students changed more than 1 point. Now, obviously, using only 3 achievement levels, there's less possibility to move. The more achievement levels you possibly could use, the stronger the correlation is going to be able to be looked at, because you're going to have less of a variance between your achievement levels. Okay, once again, let's kind of stop and reorient ourselves. I've talked a lot. So if this is the statement, if your intention with your local assessment program is to be able to look back and say, did these tests, and whatever these tests are locally developed tests, did these locally developed unit assessments, checkpoints, common assessments, CBAs, did these smaller tests or different tests, did they correlate to some other assessment? And in this case, we're using the STAR benchmark as our correlation test. But it could be a different test. You could be correlating to a third-party test. You could be correlating to your benchmark test. But if your intention is to have your assessments set up to where we have the ability to trust each one of them as preparing us for an overall score on a summative test, the stronger the correlation, the more you can trust that test. And then obviously you can prove and see that through the numbers of students that move one direction or the other. Obviously, the stronger the prediction, the less movement there's going to be at all. So the bigger the zero, obviously the stronger that ability to predict is. But either way, you want that prediction to only be moving a little bit, one point or one achievement level either direction. Once again, the metrics are the triggering values that determine what you see here, obviously go in the correlation as well. So let's review those metrics once again and how intentional you as an assessment professional need to be. So first of all, how many achievement levels are we going to use? Once again, be anywhere between 2 and 6. Once you define those number of achievement levels and you bring in those assessments, then you're going to have to determine what metric, and you see about here, what metric and what range of metrics are we going to use in order to make these comparisons. I will caution you that if you make assumptions, those assumptions might not come true. For example, we might want to use performance level to where we're getting the performance level. We don't have to go look up the scale scores or raw score conversion. We might want to do highest level achieved performance level on our local assessments because maybe we have our test aligned with the STAR kind of performance levels. We do approaches, meets, and masters too. And so if it's approaches here, we make the assumption that it's going to be approaches here, and those numbers are going to be compatible. I caution you that. For example, you might see something like this. Maybe on one test, and this was one of the unit tests we used here in this example, this demo example, you see we have these 3 different performance levels being used and these different numbers. Obviously, every test creator has the ability to enable performance levels or disable performance levels, and then obviously they can change the percentages. So this test is one of the comparative tests, and we have these, I would say, performance level 1, 3, and 5 being used, and these are the numbers as you see. Well, this is also another comparative test in the same MTA. It's using number, what I would consider 2, 4, and 5. So the other one had 1, 3, and 5. This is 2, 4, and 5. So completely different performance levels, different names, and all different numbers. So you might want to review this, obviously, with your test creators and say, if down the road our intention are to use performance levels, the indicators, the highest performance level achieved as the easy way, I'll say easy in quotes, the easy way to do comparisons in MTA, then the first thing we've got to do is we've got to make sure that we have consistency in how we're building our assessments. And obviously, if the more people that are doing this, the more possibility you're going to have for variance. And so those are just things that you have to come into play. And so obviously that's why I chose to use scores, because these scores are happening outside of the performance levels. It's truly just looking at the scores. Wanted to reiterate that because making assumptions about, hey, we're just going to use performance levels because we all use approach and meets and masters or whatever those performance levels are, you might think that is happening, but unless you prove that by looking at your tests and making sure they're set up the way that we think, it definitely might corrupt your data, or definitely in the worst way, make us draw the wrong kinds of conclusions because it's not set up the way that we think it is. So always verify your local assessments. And this is just another tool that kind of puts the magnifying glass on us to say, are we doing what we think we're doing? And if we are, this is going to give us that ability to say, is it giving us the conclusions that we want it to give for our local assessments? So MTA is a great tool. Hopefully you'll start to use it. Obviously, with any feedback and things you want to share with us, please reach out. I'm going to turn it right back over to Armando.
Jason, thank you so much for sharing that. There's a lot of things to consider as you all are working through your varied assessment plans within your district. And of course, like Jason said, if you all have questions, you can always reach out to us at training@eduphoria.net. And I just want to share a couple of last things with you all right now. We want to remind you to visit our teacher learning site for Aware and Strive at teachers.eduphoria.net. Within the teacher site, you will find modules made up of video, text learning resources, supports, knowledge checks, discussion prompts, and the length of the video content ranges from a couple of minutes to about 6 minutes in length, where teachers can get topic-specific demonstrations on utilizing Aware and Strive. We have an exciting update for the Aware portion of the learning site. New modules have been added for the following Aware Premium tools: single test analysis and mastery tracker. If you are interested in the course challenges for teachers to show what they know, fill out the interest form and we will get back to you as soon as possible. And with that, I would like to thank Jason for hosting. A lot of great information that you shared with us today. And on behalf of today's team and all of Eduphoria, we would like to thank you for joining us on today's webinar about evaluating your assessment program using multi-test analysis. Have a great day.